So we're going to take up that forming ions sheet. So anything that you have on your sheet that you're not happy with, or if you've got something wrong, no problem, we're going to fix it. So let's take a look at. So our first diagram here, we see our atom that has 3 protons in the nucleus. Now, if this has 3 protons in the nucleus, there must be 3 electrons around it. So in our first energy level here, we've got 1, 2 electrons, and that is full. That energy level is full, can't take more than 2. So our next electron must be in that second energy level. So there's our 3 electrons being placed. Now, the question is, what is the closest noble gas that this atom can look at or look like? All right, this is lithium. What can it do? Well, it can either gain 7 more electrons so that it looks like neon, or it could just lose this 1 electron and it would look a lot like helium. So with this one here, it's going to end up looking like helium. It's going to lose that 1 electron. If there's something that's close that tends to take electrons, the electron will be pulled out of this energy level. And on the outside, this is going to look like helium, even though in the inside, it still is lithium. So the Lewis diagram for this, the original Lewis diagram for this, is going to be Li, because we don't worry about the electrons in those inner energy levels that are full. We only care about the electrons in the valence shell, or that outer shell. So that's our Lewis diagram. So, like I said, if there's something around that tends to pull on electrons, this electron will be lost, and we're going to have an ion. So an ion is an atom that has gained or lost electrons and has a positive or negative charge depending on whether or not it's gained or lost electrons. So if this guy here, if this lithium loses a negative electron, it's going to become more positively charged. Now when we draw the ion diagram for this, remember it's no longer a regular atom, so we have to show that it's being changed. So we use those square brackets around it at this point right now. Soon when you get back into grade 10 and stuff, you don't always have to have these square brackets around, but for this grade we do. So we're going to have a lithium. Now, our outer energy level, remember, there's a whole energy level around here, all right? It's lost the electrons, so we don't show any electrons out here because that energy level is now empty. It's still there, it's just empty, so we don't need to show any electrons. So for our metals, we don't show any electrons around the outside. Now, since this guy lost 1 negative electron, lost part of his negative attitude, he's become more positive. And since he's lost 1 negative electron, the overall charge is going to be positive 1. So let's go to the next one here. All right, so this one here, we've got a Bohr diagram here. We've got 13 protons in the nucleus of this atom. So we know that this is going to end up being aluminum, because only aluminum has 13 protons. So we're going to draw this Bohr diagram of aluminum. So here's our electrons going in here. I know the shapes are kind of funky, but that's because I was trying to make them really noticeable. So there's our electrons. Look at this outer energy level here. All right, there's 3 electrons. So you got to ask yourself, is it easier for aluminum to gain 5 electrons to try to look like the closest noble gas, or would it be easiest for it to lose these 3 electrons from the outside so that it looks again like neon? Well, I would say it's easier for it to lose 3 than to try to gain 5 from somewhere. So the closest noble gas for aluminum is going to be neon. So if it looks like neon, it's going to be stable. So the Lewis diagram, we're going to step back there again. Our Lewis diagram is going to be aluminum with 3 electrons in the outer energy level, because those are the only ones we care about, those valence shell electrons. Those are the ones that cause all the trouble. Now, if something comes close and manages to rip those 3 electrons out of aluminum, well, aluminum is going to look like neon on the outside, even though it's still going to be aluminum on the inside. But as an ion, we have to draw what it looks like as an ion. All right, so again, it's a metal. And those 3 electrons that used to be in that outer energy level are now gone. The energy level is still there, there's just no electrons in it. And because we lost 3 negative electrons, we lost 3 negative attitudes, we've become 3 more positive, all right? So we are positive 3. We're now into the positive side here. Now, instead of having 13 electrons around the outside, we only have 10. So we have 13 protons. We have 10 electrons, so we have 13 extra positive charges on this atom. Well, now this is an ion. Okay, let's take a look at the next one. So our next one here, we have 7 protons, 8 neutrons. So we know that we need to have 7 electrons around the outside. So our Bohr diagram, 1, 2, 3, 4, 5, and we've got the 2 on the inside. The closest noble gas, right. So we got to think to ourselves, is it easier for this atom to lose 5 electrons from the outside, or to gain 3 that might be circling around from somewhere, to go into these, to pair these guys up? So what would be easiest for this? Well, I would say it's easiest to gain 3 than to lose 5. So the closest noble gas, if we were to put an electron here, an electron here, and an electron here, our closest noble gas will be neon. So on the outside we would look like neon, but on the inside we would still be nitrogen. Right, so our Lewis diagram for this is going to be our nitrogen with our 5 electrons around the outside in the energy level. Right, so now if there happens to be 3 electrons from somewhere, maybe there's a metal close by that lost some electrons, our ion diagram, we're going to draw our nitrogen in the square to show that it's no longer an atom, it's now an ion. But because this outer energy level is now going to be full of electrons, we're going to show it being full of electrons. So 1, 2, 3, 4, 5. So those were the original 5. And then I've done the other electrons in color just so that you know that these were 3 that came from elsewhere. 1, 2, 3. All right, so those are the new ones. So this shows you that the outer energy level is completely full of electrons. This thing is now stable. But it has 3 more negative electrons than it normally does have. So now its charge is going to be -3. Originally it had 7 protons and 7 electrons, but now it's got 7 protons and 10 electrons around the outside. So that gives us an overall charge of -3. Last one. Alrighty, so this guy here, we've got our big chlorine here. It's got 17 protons in the nucleus. So let's do our Bohr diagram. Let's stick them in there. Alrighty, so we've got right up to 17. Look at this little unpaired guy. You know this person's going to be causing, or this little electron's going to be causing a lot of trouble here because he's unpaired. Everyone else has pair, not this little guy. So ask yourself, what is the closest noble gas? Well, is it easiest for chlorine to lose 7 electrons around the outside, or is it going to be easier for it to gain 1 electron that might be zipping around from some metal that's lost theirs? So I would say it's got to be a lot easier for it to gain 1 electron. And if it gains 1 electron here, it's going to look a lot like argon around the outside, but deep down in its core, it's still going to be chlorine. So this closest noble gas is going to be argon. We only need to gain 1 electron in that outer energy level so that the outside looks like argon. So the Lewis diagram now for our chlorine is going to be chlorine with 7 electrons around the outside. Alrighty. Now, if that electron that's been zipping around comes in here, we're going to have an ion. Remember, an ion is a charged atom. It has greater or less electrons than normal. So this is going to be chlorine. And now it's going to have 8 electrons in its outer energy level because it's found that one that's been zipping around here. So here's our original electrons. And then in color, it's going to show you the one where it got one from somewhere else. Now, because it has 1 extra electron compared to normal, right? It used to have 17 electrons around the outside. Now it has 18. So that means its overall charge is going to be -1. So this is our ion. This is our ion with a -1 charge. Alrighty, so you have a quiz to go with this, and that's it for now.